Okay, so a couple of final types of problems that you'll run into that revolve around inequality, interval, and set notation is trying to decipher from words how we could write something in set notation. So if you'll pause the video and write these additional examples down, we'll go over them in just a minute. The space in between is where we're going to actually write our work, so leave that space in between the examples. Okay, so in this first example, we have a set that is the whole numbers 50 through 53. So we could write this in what we called before our discrete notation, because there's not very many numbers here, 50, 51, 52, 53. So we could just physically write them. And in that case, it's actually the better way to do it than trying to do set builder notation with this. And I'll show you why. So here is how we could write it as a discrete notation. Or if we try to use our set builder notation, here's what happens. We have all real numbers x such that 50 is less than or equal to x is less than or equal to 53. However, that includes all the real numbers, and we don't want the real numbers. We just want the ones that are whole numbers. So we have to remember the symbol for whole numbers and add on to this. So we're going to say and x is a member of the set of, this little funny looking E means is a member of the set of. And what is it a member of the set of? It's a member of the set of whole numbers. So we're going to draw that fancy W with kind of the extra wide pieces on it, and then close off our brackets. So notice how much more I had to write just now than just writing those few numbers. So occasionally set notation by itself works better than our set builder notation, where we start with all real numbers and then restrict it. If we want the integers from negative 100 through 100, we could do that as set notation as well. We'd start with negative 100, negative 99, negative 98, and go all the way through positive 100. That's a lot of numbers to write. So that's when our set builder notation is actually a good shorthand. So we start here with x, all real numbers x, such that negative 100 through 100. So we have negative 100, x in the middle, and 100 over here. So x is in between, and it's all those numbers through negative 100 and 100. So we have the or equal to part. But this is all real numbers still. We need to restrict it to integers. So we also have to add, and x is a member of the set of integers, and the symbol for integers is the z. All right, finally, natural numbers between 5 and 36. I want you to notice the word between here. Okay, so between means that it's in the middle, but it doesn't include it. So we would not have an or equal to in this case. So all real numbers x such that 5 is less than x is less than 36. So again, it doesn't include 5, doesn't include 36, and it also doesn't include everything between 5 and 36. It only includes the natural numbers. So we have to add, and x is a member of the set of natural numbers, which is the funny looking n, and close our braces. All right. I also want to go over just a couple of special cases real quick that you might run into. So let's look at those. So we'll call this example 8. And if you want to title this special cases. Sometimes when we write our interval notation, there's not just one interval. we might have negative infinity to 2, or x might be over here on the other side from 10 to infinity. So let's take a look at this. Let's think about that for a second. So if we were to draw a number line for that, I've got negative infinity over here. I've got 2 somewhere and 10 and positive infinity there. I know that I'm headed towards negative infinity or I'm headed towards positive infinity, but my critical points are 2 and 10 gets a filled in circle. All right, so I'm somewhere between negative infinity and 2 as one possibility. So we'll draw a line headed towards negative infinity. But my other option is that it could be between 10 and infinity. So where is x? X is either here or it's here, and it is not in here. Okay, it does not exist just to the other side, or from 2 all the way to 10, not including 2. So it gets super, super close to 2, 1.99999, and then jumps all the way to 10. So if we want to write this in our set builder notation, we would write all real numbers x such that x is less than 2, or we just have to write the sign, or the word or, x is greater than or equal to 10. All right, if we wanted to write this in inequality notation, just take off the fancy stuff. And the stuff in the middle is our inequality notation, so I'm not going to write it again. One more example and then we're done. Example 9. We're going to go from negative infinity to negative 3, or negative 3 to infinity. Now wait a second. We've got like the same point twice. We have negative 3 in both of these. So let's think about what that would look like on a number line. I know that I've got negative infinity over here, positive infinity over here, and somewhere in between is negative 3. Now I have a parentheses here on this interval, so that would indicate an open dot at my critical point, my end point. I also have a parentheses here at that same critical point, so it's still an open circle on my graph. And so basically x is to the left of 3, or it's to the right of 3, negative 3, but it can't actually be negative 3. So if we were going to write this in set notation, x, all real numbers x, such that x is not equal to negative 3. That's the only thing in the entire set of real numbers that x can't be equal to. Again, if you wanted to write inequality notation, that would be here. So I just wanted to show you this couple of special cases before you jump to your classwork assignment. Please let me know if you have any questions.